Here we are solving Pure Math 3 January 2024 paper. In the previous two videos we covered question number 1 to 6. In this video we are starting from question number 7. We have a function given, a curve C with equation y is equal to this, x is not equal to k over 3, because when you put k over 3 here in the place of x, the denominator becomes 0. That's like an asymptote of this graph, where k is a positive constant not equal to 3. Find dy by dx. Write y as 16 over 9 3x minus k to the power negative 1. Differentiate by applying chain rule. So you can take this thing as x. We have x power minus 1. So you put a minus 1 in front. X power minus 1, which is minus 2 times, differentiate the highlighted one, you will get 3. Cancel this, 3 3s are 9. So dy by dx is basically negative 16 over 3 3x minus k power negative 2. That's all, just a 2 mark question. Let's move on to part B of the question. The point P with x coordinate 1 lies on C. A point P with x coordinate 1, we don't know the y coordinate. Given that the gradient of the curve at P is minus 12. To find the gradient of the curve at P, you need to take the differentiation, the first derivative of y, which is negative 16 over 3 3x minus k power negative 2. In this first derivative, replace x by the x coordinate of the point. So it becomes minus 16 over 3, 1 over 3 times 1 minus k, x is 1, power positive 2. This is the gradient, which is same as negative 12, which equals to negative 12. And then we need to solve for k. Bring the negative 16 over 3 to the other side, you will get 1 over 3 minus k whole square is negative 12 times negative 3 over 16. So negative 12 times negative 3 over 16 is 9 over 4. So flip both sides, you will get 3 minus k whole square is 4 over 9. Take the square root, you will get plus or minus square root of 4 divided by square root of 9. So bring the k here, this number here. So you will get k is equal to 3 plus or minus 2 over 3. So when you take the positive 3 plus 2 over 3, you will get 11 over 3. 3 minus 2 over 3, you will get 7 over 3. That's why the question says 2 possible values of k. That's all. It's a 3 mark question. Let's move on to part C now. Find the equation of the normal. To find the equation of the normal, we need that slope. The slope at the point P, which is given as the slope of the tangent is given as negative 12. So slope of the normal would be 1 or positive 1 over 12. And you need the point. Only the x coordinate is given. We need to find the y coordinate. So we take the original function, this function, replace x by 1 and sub in the value of k. Y is equal to 16 over 9 times 3x minus k. That's the function. It says k is smaller than 3. We got two values of k. One is 11 over 3, which is bigger than 3, 7 over 3. So we need to take 7 over 3. So x is 1, k is 7 over 3. Sub in here into y. Y is 16 over 9 times x is 1. So 3 minus 7 over 3. Just simplify this. So you will get 16 over 9 times 3 minus 7 over 3. So we'll get 8 over 3 is the y coordinate of the point. Now we have a slope, we have a point, we can find the equation of the normal already. The formula is, they want the answer in this form. without any fraction. So y minus y1, the point is x1, y1. So y minus y1 is equal to slope times x minus x1. Multiply throughout by 12, you'll get 12y minus, when you multiply this by 12, you'll get 4 8s or 32 is x minus 1. Put everything one side, you will get x minus 12y plus 31 is equal to 0. That's the equation of the normal. In a 3-mark question. Part D of the question, they want us to integrate it now. Here they did not specifically mention about CAIE, so we are going to use the value of CAIE as 7/3, which is what mentioned in the previous part. CAIE is less than 3, so 7/3. So replace CAIE by 7/3 and integrate it. You need to remember this rule. Integral of 1 over a linear function dx is equal to ln modulus the linear function divided by the coefficient of x plus c. So in this case you can keep 16/9 outside, ln modulus 3x minus k divided by coefficient of x. But I'm going to replace k by 7/3. And then the limit is 1 to 3. He is given us lambda 10. So probably we write this whole thing in the form of lambda ln 10. You don't need to equate it to lambda ln 10. So the next step is going to be 16/9. We are going to sub in the upper limit, lower limit. Replace x by 3. So you will get 3 3s are 9. So you'll get 3 3s are 9 minus 7/3, which is 20/3. ln, I can take this 3 also as a common factor. I'll put it as 99/3. So what I'm going to do, I'm going to write it as 16/9 times 3, and then sub in the upper limit ln, we got 20/3 minus ln, sub in the lower limit 3, so 3 times 1 is 3 minus 3/3, 9 minus 7, which is 2/3. And we know the laws of logarithm. We can write it as 16/27. ln a minus ln b is ln a over b. So 3 3 will be cancelled. 20/2 is ln 10. 16/27 ln 10. This looks exactly like this, where lambda is equal to 16/27. That's all. 4 more questions. Question number 8 now. We have a modulus function given, the graph representing modulus function. Let's read the question. The graph shows figure with the equation y is equal to a minus modulus 2x minus b, where a and b are positive, a is bigger than b. Okay, find, giving your answer in terms of b, the coordinates of the maximum point of the graph. If you look at the graph, the maximum point is same as the vertex. Finding vertex is one of the very important questions. So the shortcut to finding vertex is this. You can take this 2x minus b, whatever in the modulus, equate it to 0 and find x. That's the x coordinate. And the number standing all alone outside modulus is the y coordinate. So vertex is b/2 comma a. That's the vertex. This is b/2 comma a. So basically this is a, this point is b/2. You don't need to mention this on the graph. I'm just mentioning it. Probably we might use these values in the next part or something. Now find the coordinates of the point of intersection, part II. It says find the coordinates of the point of intersection of the graph with y-axis. To find the y-axis, we replace x by 0. So when you replace x by 0, you get y is equal to a minus modulus of minus b. We know b is positive, minus b is negative. Modulus of minus b becomes just b, right? Because of the modulus sign. So the point is 0 comma a minus b. That's the y-intercept, means this point is a minus b. And then the next one, find the x-intercept. How do we find the x-intercept? We need to replace y by 0. So when you replace y by 0 into the function and take the positive and negative argument separately, so you will get a is equal to modulus 2x minus b. When you put this modulus 2x minus b this side, take the positive and negative argument separately. A is 2x minus b, or a is minus of 2x minus b. Make x as a subject. You get x is equal to a plus b over 2. Here a is minus 2x plus b. So you will get b minus a divided by 2. So we got 2 points. A plus b over 2 comma 0. That's the first x-intercept. B minus a over 2 comma 0. Now let's say in the graph the points are mentioned as a and b. Instead of just asking you to find the x-intercept, they want you to find the coordinates of a and b. We have 2 points, a plus b over 2 0, b minus a over 2 comma 0. You cannot just put random point here, another point here. That's wrong. You need to read the question carefully. The question clearly says a is the bigger number. What does that mean? So when you put b minus a, you will get a negative number. Since both are positive, this will be a positive number. So this point b is going to be a plus b over 2. Point a is going to be b minus a over 2. So you need to check this and mention it properly. But in this case, they did not specifically say, they just say, the question just said find the x-intercept. So just mention these 2 points in any order. You will get full mark. Part B says it's a 2 mark question. They want you to sketch modulus x minus 1 on this diagram, top of this diagram. Always remember this, modulus x is this graph. This is modulus x. So when you put minus 1, you need to move the graph downwards 1 unit. So the graph would be here. That's all. This point is negative. That's the graph. They did not specifically say anything else, so just mention the graph, just draw the graph. You'll be given 2 marks here. Now part C of the question says, given that the graph modulus x minus 1 and the modulus graph intersect at 2 points, find the value of a and b. So if you look at the graph, this point, the x coordinate of this point is minus 3, and then the x coordinate of the next point is 5 actually. So we have 2 functions. One is this, another one is a minus modulus 2x minus b. Now instead of just blindly taking positive argument, negative argument, equate them, you have to look at the graph. First, for the modulus graph, this is the positive arm actually. What does that mean? The one with the positive slope, the line with the positive slope. So what you need to do, you need to take the slope as positive. So you need to take it as a minus, take the negative argument to get the positive slope. Hope you understand this. Because this modulus can be written as minus of 2x minus b or just 2x minus b, right? So we need to take this actually, so that when you open the bracket, you will get a positive slope. You will get it as a plus 2x minus b. Equate it to the negative arm of modulus x minus 1. So you need to take the negative argument so that you'll get a negative slope here, negative x minus 1. Hope you understand this. And then find x from here. So you'll get, bring the x here, 3x is equal to minus 1 minus a plus b. We know the value of x already, minus 3 at that point. So replace x by minus 3, you will get minus 9 is equal to minus 1 minus a plus b. So put this minus 1 here, you'll get minus 8. Minus a plus b is equal to minus 8. Take it as equation 1. So we got the first equation already, and we need to find the second equation. So I'm going to take the negative arm actually. That means the line with the negative slope. To get the negative slope, I need to take this as a minus of 2x minus b. Otherwise, it's going to be a minus 2x plus b. The slope is the coefficient of x, right, which has a negative slope, is equal to the positive arm of this function. This function, it has to have a positive slope. So I'm going to take it as x minus 1 and solve again. So I'm going to put this minus 2x this side. So a plus b is equal to 3x minus 1. And we know x is 5 at this point. So replace x by 5. You will get 15 minus 1 is 14. A plus b is equal to 14. That's number 2. So now listen to me carefully. This is just solving simultaneous equation. You can find the values of a and b. But here, this is what you need to understand. Whenever they are talking about point of intersection of two modulus graph, when you have the graph, look at the graph. The first one is a line with the negative slope, and then the line with the positive slope. You need to take the corresponding corresponding function. You need to take the modulus of the modulus can be split into positive argument and negative argument. So don't take this one positive argument, because if you take the positive argument, the slope will be minus 2x here. Hope you understand this. Just go through this video again, you will get it. We got two equations, we just need to solve it. So go to equation number 1, simultaneous 1, 1, 14. Negative 1, 1, negative 8. A is 11, B is 3. So A is equal to 11, B is equal to 3. That's all. That's the answer for this question. A is 11, B is 3. It's a 4-mark question. So that's part C of question number 8. I need to explain one more thing here. When you sketch these two graphs in part B, listen to me carefully. You can draw the graph here, you can draw the graph here, or you can draw the graph this way. These are all correct. What you're not supposed to do, don't draw the graph as if they have a point of intersection on x-axis. That's wrong, because we are not sure whether the point of intersection is on the x-axis. So that's wrong. Otherwise, you can draw any of this graph. You can draw here, or you can draw here. These are all okay, but this one is wrong. So that's all. I'm going to move on to question number 9 now. Question number 9, show that this equation can be written in this form. We need to rewrite this whole equation. You need to take the whole equation, apply identities, and rewrite it in this form. So straight away I can see 3 sine 2 theta here. So what I'm going to do, we know sine 2 theta is equal to 2 sine theta cos theta. You bring the 2 here, so we can write this as 3 over 2 sine 2 theta is equal to, I'm going to bring cos plus sine here, so it's going to be 2 plus secant 2 theta times cos theta minus sine theta times cos theta plus sine theta. Hope you understand this thing. When you multiply a plus b times a minus b, you can write it as a square minus b square. I'm going to write it in the next slide. 3 over 2 sine 2 theta is equal to 2 plus secant 2 theta times cos square theta minus sine square theta. We know cos square plus sine square is cos 2 theta. So it's 3 over 2 sine 2 theta is equal to 2 plus secant 2 theta times cos square minus sine square is cos 2 theta. Take cos 2 theta and multiply these two. You'll get 3 over 2 sine 2 theta is equal to 2 cos 2 theta. When you multiply secant and cos, secant is 1 over cos, so these two will be cancelled. You'll get just plus 1. Multiply throughout by 2, you'll get 3 sine 2 theta is equal to 4 cos 2 theta plus 2. Put this thing here. We got the equation already. Minus 4 cos 2 theta is equal to 2. That's what they want us to prove. This equation. That's it. It's a 3-mark question. Part B of this question. They want you to solve this equation. We have already rewritten this equation as sine 2 theta, in this case 3 sine 2x minus 4 cos 2x is equal to 2. Now I want you guys to listen to me carefully. Let's say there is no number here. Instead of 2 you have 0. They want you to solve this equation. It's very easy. Divide throughout by cos 2x. You'll get sine over cos is tan 2x. Here the cos 2x will be cancelled. Tan 2x is equal to 4 over 3. Solve this using the method you learned in P2. It's very easy when you have e is equal to 0 on the other side. But the moment you have a number, you cannot divide by cos theta, cos 2x, because you will get 2 over cos 2x here. Again, you need to get rid of this cos 2x. It's going to be very difficult. So remember this, when you have sine and cos with the same theta, but on the other side if you have a number, you need to apply the method r and alpha. You have to write this as r sine 2x minus alpha or r cos 2x plus alpha. That's how you convert them into an equation of a single trigonometric function. So what I'm going to do, I'm going to take this separately, equate it to, I'm going to take 3 sine 2x minus 4 cos 2x and equate it to r sine of 2x plus alpha. So sine A cos B minus r cos A sine B. Compare the coefficient of sine 2x on both sides. You'll get r cos alpha is equal to 3. Equation number 1. Compare the coefficient of cos 2x both sides. You'll get r sine alpha is equal to 4. Equation number 2. When you multiply, square the equations and add them, 1 square plus 2 square, you can straight away write r square is equal to 3 square plus 4 square, because you will get cos square, r square cos square plus r square sin square. Take r square as a common factor. Cos square plus sin square is 1. You should have learned this method. So r is square root of 9 plus 16, 25. r is 5. And then to find alpha, you divide the second equation by the first equation. r will be cancelled. You will get tan alpha. Sin alpha by tan alpha is 4 over 3. And then you can find alpha from here. Tan inverse of 4 over 3. Use the radian mode. Tan inverse of 4 over 3. Okay. They want the answer to 3 significant figure. But still, I'm not going to round it. I'm going to store it as A. I'm going to store the value as A. 927, etc. So alpha is 0.927, etc. So what I'm going to do now, I'm going to rewrite this whole thing as r. R is this sine 2x minus alpha 927, etc. is equal to 2. And then we need to solve this equation in the given limit. The limit is this. But since it's a harder trigonometric question, we need to multiply throughout by 2. So it's going to be 2 pi is less than 2x is less than 3 pi. Hope you understand this step. You should have learned this in P2, how to solve harder trigonometric equation. So we need to solve it between 2 pi to 3 pi. Bring the 5 to the other side and find sine inverse of it. 2x minus 0.927 etc. is sine inverse of 2 over 5. That's the principal value. Sine inverse of 2 over 5 is this. I'm gonna store it as b 0.411 etc. Now I draw the ASTC diagram. You see the limit was pi to 3 pi over 2. So when you multiply throughout by 2, it becomes, this limit becomes 2 pi to 3 pi by 2 times 2 will be cancelled. 2 pi to 3 pi. So here this is 0 pi. When you go first round, it's 2 pi. But we need to take the half semicircle of the second round actually, from 2 pi to 3 pi now. Not the first circle, the second circle. 2 pi to 3 pi. And then sine would be positive here and here. So here it's going to be 2 pi plus theta. Here the angle is 3 pi minus theta. So I'm going to calculate these two angles and write it as 2x minus 0.927 is equal to 2 pi plus 0.111 and 3 pi minus 0.411. And then bring this here, so you need to add this to both and divide by 2, so you will get x. And then when you get the final answer, you need to compare it with not the modified limit, the actual limit given in the question, which is pi to 3 pi over 2. That's the actual limit. If you want, you can find the decimal values of it. Pi is basically 3.1415. So it's 3.14 etc. to 3 pi by 2. 3 pi by 2 is basically 4.71. So your answer should be between this. So I'm going to calculate these two values first. So 2 pi plus the principal value, I stored it as b, plus 0.927, I have stored it as a already, is equal to divide by 2. They want the answer to 3 significant figure, so the answer is 3.81. 3.81. Come on. The next one, 3 pi minus the principal value. 3 pi minus the principal value plus 0.927, which is being showed as a, divide by 2. 4.97. Yes, but when you compare these two values with the original given limit, only 3.81 lies in the limit. So the final solution is x is equal to 3.81. That's how you solve this trigonometric equation.